So the idea of an upper bound or a least upper bound is probably one that is new to most of us. But the idea is that if we have a set of numbers, whether it's a finite set or an infinite set, every element in that set is less than or equal to an upper bound. So for example, I like to think about this in a visual sense, okay? So if I list my numbers down here, like first number, second number, third, etc., all of these numbers, let's say they're, some numbers like this, all of them have to be less than or equal to an upper bound. Now, I could say that this number right here, let's say this is like y equals 10, I can say y equals 10, so 10 would be an upper bound for all of those numbers because all of these points are below y equals 10. However, that's not the least upper bound because maybe y equals 9.5 is this line, and maybe it's above all of those. Or we can get all the way down to whatever, yeah, we'll pretend that that one right there is the top one. But the idea is for the least upper bound, we want to get as absolutely close to being an upper bound without having any of the elements in the set go above that, okay? So if we look at the example they give over here, this is from the book. So in the set 1, 2, 3, 4, 5, 6 would be an upper bound, but it's not the least upper bound because we can get smaller without being below any of the numbers in the set. So 5 is the least upper bound because all of the numbers in set S are less than or equal to 5. Okay? Okay, so let's look at some of the examples that are given to us, or the questions. So first we have for part A, we have -10, -8, -6, -4, -2. Because this does not have an ellipses, the ... that means this is a finite set. So we just need to take the highest of all of these numbers, which is -2, and that is our least upper bound. Okay? And then for this next one, we can see that we have a pattern. This is an infinite set, but it'll continue forever, adding ones behind it. So -2.11111, and then, continuing on like that. If we think about where these numbers are on the number line, -2 is here, -2.1 is to the left of that, -2.11 is to the left of that, 2.11, -2.111, etc. And the numbers are going this direction, okay? So the least upper bound, again, the smallest number that all of those numbers are less than or equal to is going to be -2. Okay, so -2 is the answer for part B as well. All right, now part C is a little bit different because now we are going the other direction. All right, so we have 2.4, 2.44, 2.444, etc. Okay, and your first instinct might be to say, okay, well, what about 2.5? Okay, so what about 2.5? Because 2.5 those numbers are never going to reach 2.5, which is correct. So 2.5 is an upper bound, but is it the least upper bound? Okay, and the answer there is no, it's not, because 2.45, for example, is lower than 2.5, but is still above all of these numbers, okay? And then we'll say, well, so is 2.445, okay? And we can see that we run into a problem where we could keep doing that forever, all right? So the best option here is to figure out how to represent the highest number in this set. And the highest number in this set is going to be 2.4 repeating, okay? Which, if we change that to a fraction, is going to be 2 4/9, which is 22/9. And I am going to post a separate video on shortcuts for converting between repeating decimals and fractions back and forth. So if you have a question on how I did that, I'll get to that in a different video. All right, so 22/9 is 2.4 repeating, and that is the highest number in set C, okay? For sets D and E and F, well, for D, for D and E, I would recommend that you start by writing out what these numbers are. Like actually write what 1 minus 1/2 is, and then 1 minus 1/3 and 1 minus 1/4, and see if you can find a pattern. Same thing for set E, okay? And also I'm going to go through a separate video on how to read set notation and how to say some other symbolic things, so keep an eye out for that. But start with writing out some examples. See if you can find the pattern. If you're not sure, I am going to post a follow-up video to this very shortly that explains the last ones in a little bit more detail.